Welcome to our comprehensive guide on MATLAB interview questions focused on technical computing. MATLAB, which stands for Matrix Laboratory, is a powerful programming language and interactive environment widely used in engineering, scientific computing, and data analysis. Today, we'll cover the essential topics that frequently appear in technical interviews, including matrix operations, Simulink for system modeling, various toolboxes for specialized applications, and engineering problem-solving approaches. Whether you're preparing for your first MATLAB interview or looking to strengthen your technical knowledge, this session will provide you with the fundamental concepts and practical insights needed to succeed. MATLAB, short for Matrix Laboratory, is a high-level programming language designed specifically for numerical computation, visualization, and application development. It provides an interactive environment that allows engineers and scientists to express mathematical concepts directly in code. The key strength of MATLAB lies in its matrix-based operations, which make complex mathematical calculations intuitive and efficient. MATLAB comes with an extensive ecosystem of built-in mathematical functions covering areas like linear algebra, statistics, signal processing, and optimization. This rich functionality, combined with its rapid prototyping capabilities, makes MATLAB an ideal choice for research, development, and industrial applications where quick iteration and reliable results are essential. Matrix creation and manipulation form the foundation of MATLAB programming. To create a matrix, you use square brackets with semicolons separating rows and spaces, or commas separating columns within each row. For example, A equals open bracket 1 2 3 semicolon 4 5 6 semicolon 7 8 9 close bracket creates a 3 by 3 matrix. MATLAB provides convenient functions like zeros, ones, and I for creating special matrices. The zeros function creates matrices filled with zeros, ones creates matrices filled with ones, and I generates identity matrices. Matrix indexing in MATLAB uses parentheses and follows a one-based indexing system, meaning the first element is at position 1, not 0. You can access individual elements using row and column indices, entire rows or columns using the colon operator, and extract submatrices by specifying ranges. MATLAB distinguishes between element-wise operations and standard matrix operations, which is crucial for interview success. Element-wise operations use the dot operator and perform calculations on corresponding elements of matrices. For addition and subtraction, you simply use plus and minus signs, as these are naturally element-wise. However, for multiplication, division, and exponentiation, you must use dot asterisk, dot forward slash, and dot caret respectively to perform element-wise operations. Standard matrix operations follow linear algebra rules. Matrix multiplication uses the asterisk symbol without the dot, transpose uses the apostrophe, and MATLAB provides built-in functions for common operations like in for matrix inverse, det for determinant, and rank for matrix rank. Understanding when to use element-wise versus matrix operations is fundamental and frequently tested in interviews. Simulink is MATLAB's graphical programming environment designed for modeling, simulating, and analyzing dynamic systems. Unlike traditional text-based programming, Simulink uses a block diagram approach where you drag and drop blocks to represent different system components and connect them to model signal flow. This visual programming method is particularly powerful for complex system design, control systems, signal processing applications, and real-time simulations. Key features include drag-and-drop modeling from an extensive library of predefined blocks, real-time simulation capabilities that allow you to see system behavior as it evolves, automatic code generation for deployment to embedded systems, and specialized tools for signal processing and control system design. Simulink bridges the gap between conceptual system design and practical implementation. Simulink organizes functionality into different categories of blocks, each serving specific purposes in system modeling. Source blocks generate signals and include components like signal generators, step inputs, and ramp functions. Function blocks perform mathematical operations, transformations, and logic operations on signals. Sync blocks display or store simulation results and include scopes for visualization, displays for numerical values, and workspace outputs. Signal routing blocks like multiplexers and switches control signal flow and connections. Continuous blocks handle continuous time operations, such as integrators and transfer function blocks. To run simulations, you can use the sim command followed by the model name, or control simulations programmatically using set_param functions. The simulation results can be accessed and analyzed in the MATLAB workspace, making it easy to post-process and visualize your system's behavior. MATLAB's power extends far beyond its core functionality through specialized toolboxes that provide domain-specific functions and algorithms. Popular toolboxes include signal processing for digital signal analysis and filtering, control system for designing and analyzing control systems, image processing for computer vision and image analysis, statistics and machine learning for data analysis, deep learning for neural networks, optimization for solving complex optimization problems, curve fitting for data modeling, and symbolic math for symbolic computation. Each toolbox provides pre-built, validated algorithms developed by domain experts, comprehensive documentation with practical examples, interactive GUI tools for ease of use, and seamless integration with core MATLAB functionality. These toolboxes enable rapid development by providing tested, optimized solutions for complex engineering and scientific problems, allowing you to focus on your specific application rather than implementing basic algorithms from scratch. Effective engineering problem solving in MATLAB follows a systematic workflow that ensures reliable and efficient solutions. The process begins with clearly defining the problem statement and identifying all known variables and constraints. Next, you choose appropriate mathematical methods and algorithms based on the problem type, whether it involves numerical integration, optimization, root finding, or curve fitting. The implementation phase involves writing clean, well-documented MATLAB code that efficiently solves the problem. Validation and verification are critical steps where you test your solution against known results or theoretical expectations. Finally, document your solution and create meaningful visualizations to communicate results effectively. MATLAB provides robust built-in functions for common engineering tasks, including F0 for root finding, ODE45 for solving ordinary differential equations, fmin-BND for bounded optimization, and polyfit for polynomial curve fitting. This systematic approach ensures reproducible, reliable solutions to complex engineering challenges. Technical interviews often focus on fundamental MATLAB concepts that demonstrate your practical understanding. Common questions include explaining the difference between dot asterisk and asterisk operators, where dot asterisk performs element-wise multiplication, while asterisk performs matrix multiplication. You might be asked about creating sparse matrices using the sparse function, which is essential for memory-efficient handling of large matrices with mostly 0 elements. Vectorization is another frequently discussed topic, referring to the practice of replacing explicit loops with vector operations for better performance and more readable code. Interviewers often ask about the clear and CLC commands, where clear removes variables from the workspace and CLC clears the command window. Advanced topics include MATLAB's memory management strategies, the distinction between handle and value classes in object-oriented programming, and when to use cell arrays versus structures for organizing heterogeneous data. Understanding these concepts demonstrates both theoretical knowledge and practical experience with MATLAB development. Success in MATLAB interviews requires both technical preparation and effective communication skills. For technical preparation, practice coding exercises regularly to maintain fluency with MATLAB syntax and functions. Develop deep knowledge of relevant toolboxes for your target role. Understand performance optimization techniques like vectorization and memory management. And master MATLAB's powerful visualization capabilities for presenting results clearly. Communication skills are equally important in interviews. Always explain your thought process when solving problems, as interviewers want to understand your problem-solving approach. Document your code clearly with meaningful variable names and comments. Don't hesitate to ask clarifying questions about problem requirements, and demonstrate a collaborative mindset by discussing how you would work with team members. Remember that consistent practice builds confidence, and confidence helps you perform your best during interviews. Stay curious about new MATLAB features and applications, as this shows genuine interest in the field and commitment to continuous learning.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.